Hi friends, myself Aniket Vishnu Renavikar, Assistant Professor, Center for Distance Education, Shivaji University, Kolhapur. In MCOM Valuation of Real Estate program, in semester second, the subject is building construction first. In that subject, the first topic is the soil or the building material soil or material of soil. In that topic, we can see the various objects. In that, definition of soil engineering, constituents of soil, properties of soil components, particle size distribution of soil, soil consistency, bearing capacity of soil, compaction of soil, moisture content in soil. These are points to be covered in this topic. So we can start in the formation of soil. Soil engineering may be considered as a branch of engineering involving the study of soil, its behavior and application as an engineering matter. While the application of the laws, principles of mechanics and hydraulics to engineering problems dealing with soil is usually referred to as a soil mechanics. The term soil engineering is currently used to cover a much wider scope, implying that it is a practical science rather than a purely fundamental or mathematical one. This is true because of practical considerations. Soil engineering cannot approach exact science. Soil is a natural powder of rocks which may contain air, water and any other substance laying therein and which is used for construction and plantation purpose. As per the IS 2809-1972, soil is the sediments or other unconsolidated accumulation of solid particles produced by physical and chemical disintegration of rock. In the constituents of soil, soil has three constituents, namely soil particles or solids, air and water. These three constituents are blended together to form a complex material. The complex material is called as a soil. The space occupied by air and water in a soil man is termed as voids in the soil man. In the formation of soil, there is a geological cycle continually taking place on the face of the earth, which results in the formation of soil. The cycle of events consists of weathering, transportation, deposition, and again followed by weathering and so on. So, in the formation of soil, there is a point to be considered as a four cycles. In that, weathering, transportation, deposition and upheaval. Again followed this procedure in various points. Next point is a properties of soil components. In that properties, first is a gravel and sand. Both gravel and sand have essentially the same engineering properties, differing mainly in degree. When clean, that is when having no fine grained soil or fines, they are pervious, easy to compact, little affected by water and not subject to frost action. They have high internal friction but no cohesion. Silt and clay. Presence is small in amounts of fine grained soils may considerably affect the engineering properties of soil. And organic matter. Partly decomposed vegetable matter is in the main constituents of peaty soils. Silts and clay having varying amounts of finely divided vegetable matter are described organic silt and organic clay. Next point is a particle size distribution. Soils are classified for the purpose of arranging them in one group. According to their behavior and characteristics, they are divided into two groups of engineering and architectural, or engineering and agricultural. This classification is according to IS 1498-1970 in which soil are classified into subgroups according to their particle size, or in that we can formation of type of soils. First is a clay. Clay is less than 2 micron or less than 0.002 mm. Next is a silt. Silt is rise between 2 micron to 75 micron, or 0.002 mm to 0.075 mm. Next is a sand. Sand is 75 micron to 4.75 mm, or 0.075 mm to 4.75 mm. In that sand there is a three part of this: fine sand, medium sand and coarse sand. Fine sand lying between 0.075 mm to 0.425 mm. Medium sand is 0.425 mm to 2.0 mm. Coarse sand is 2.0 mm to 4.75 mm. Next is a gravel. Gravel is lying between 4.70 mm to 80 mm. In that there are sub two parts. There is a fine gravel and coarse gravel. Fine gravel is 4.75 mm to 20 mm, and coarse gravel is a 20 mm to 80 mm. Next is a cobble. Cobble is 80 mm to 300 mm, and boulders are more than 300 mm. These are the various types of soil or particle size distribution of the soil. Next is the soil consistency. The soil consistency term is applicable to fine-grained cohesive soils like clays or clay mixed silts or clay mixed fine sand. Consistency means the relative case with which soil can be deformed. In general term, soil consistency is described as soft medium, steep, very steep. A clay may be almost like a liquid, or it may be hard, solid, depending upon its water content. Next point is a bearing capacity. The conventional method of foundation design is based on the concept of bearing capacity. The foundations are so designed that the stress induced in the soil or within its capacity, called the bearing capacity. If the soil is overstressed, shear failure may occur, causing the soil to slide sideways from underneath and cause its failure. So in the bearing capacity of soil, the part is a safe bearing capacity. In this safe bearing capacity of soil is carried out by the maximum pressure which the soil can carry or safely without risk of shear failure is called safe bearing capacity of soil. The soil can carry the bear the load or bear the load without any bear the pressure without any risk of shear failure is called as safe bearing capacity of soil. Ultimate bearing capacity divided by reasonable factor of safety is called as safe bearing capacity of soil. The design of foundation is done for this bearing capacity. Factor of safety is foundation design range from 3 to 5 or even more. The value of factor of safety will be dependent upon importance of structure, differential settlement and soil strata. The next point is the factors affecting bearing capacity. There is a various factors in that: type of soil and its physical properties, amount of allowable total and differential settlement, position of water table, physical features of the foundation such as type of foundation, size and shape of foundation, rigidity of the structure. Next point is methods of improving bearing capacity. There are various methods we can use for the improving bearing capacity of soil. First is a compaction of soil. Second is proper drainage of soil. Increase in depth of foundation, increase the width of foundation, grouting process, and use of chemicals, replacement of poor soil. These are the various methods which can be used for improving the bearing capacity of soil. Also, the plate load test is an excellent method of determining bearing capacity of soil. It should be preferably done at a depth of proposed foundation. We can use this plate load test as per the IS 1888-1982. Also, the compaction of soil is also important part in the soil. Compaction means the process of packing soil particles closely together by mechanical means, thus increasing the dry density of soil. By this process, reduction in voids of soil mass takes place rapidly by the blow of hammer or due to vibration or by passing a roller. The compaction is done. What is the purpose of compaction of soil? Compaction is a loosely placed soil mass is necessarily to achieve the desirable properties towards better performance of the deposit. The main objective of compaction is to increase the density and shear strength, to reduce permeability, to reduce post-constructional settlements, to reduce the danger of piping, to increase the resistance towards erosion. Also, we can use moisture content at compaction has a great influence in achieving the desired dry density. In laboratory, a relationship between dry density and optimum water content is established for the soil to be used for compaction, and control values so obtained be utilized in the field to achieve the desired compaction. Also, we can use Proctor compaction test. This test is used to determine moisture content dry density relationship as per the IS 2720 part 7 and 8. There are various factors are affecting for the compaction, that is the type of soil, amount of compaction and water content. These are the various factors to be affecting the compaction. Also, use of admixture which are affecting the compaction. So friends, today we are stop here. We can see in this topic there are various points to be covered in this topic, almost all the points to be covered. In that we can we can learn in this topic is definition of soil engineering, constituents of soil, properties of soil components, particle size distribution, types of soil, soil consistency, bearing capacity of soil, in that safe bearing capacity, factors affecting bearing capacity, methods of improving bearing capacity, plate load test. Also, we can see the compaction or purpose of compaction of soil, moisture content, Proctor compaction test, factor affecting compaction. These are should be we can learn in this topic. So friends, today we stop here. You can have any doubt or any query, you can contact the following mail ID, the cde_multi@unishivaji.ac.in. Thank you very much.